This video is on single replacement reactions and the activity series. So going back again to John Dalton's atomic theory, he stated that chemical reactions occur when atoms are separated, joined, or rearranged. This video is going to talk about atoms that are rearranged. In a single replacement reaction, we have a single replacement happening, so one element switching with another. Here, metals switch with metals, or nonmetals are going to switch with nonmetals, but only like items can switch. This can only happen if the compound gains a more reactive metal or nonmetal. And we'll talk about that in a minute in regards to the activity series. So first, just looking at the format, I have zinc plus copper 2 nitrate. Okay. I have copper, nitrate, and zinc. Zinc is a metal, so it's going to switch with a metal in copper 2 nitrate. My metal in copper 2 nitrate is the copper. So the copper and the zinc are going to swap places. So that means copper is going to now be by itself, and the zinc is going to go where the copper was. So that's zinc nitrate. To write that out, zinc plus copper 2 nitrate, my zinc and my copper switching places. So that means copper is now by itself, and I have zinc nitrate written there. I double check for diatomic. Zinc and copper are both metals, so not diatomics, and I'm balanced. I can do the same thing with metals as with nonmetals. So here I have bromine and sodium iodide. Bromine, which is a nonmetal, is going to switch with the non-sodium iodide, which is my iodine. That's my anion, which came from a nonmetal. So they swap places. So that means iodine, remember when it goes by itself, it has an I-N-E ending. Iodine plus, now sodium stays the same. And then I have bromide because now it's in a compound. I have bromine, Br, plus sodium iodide, Na, makes iodine, that's the element, plus sodium bromide. Now I go back and check if I had diatomics. Bromine is a diatomic, so it's Br2. Iodine is also a diatomic, so I have a 2 here and a 2 there. Now, like I said before, these metals, switching with metals or nonmetals with nonmetals, only happen if the compound gains a more reactive metal or nonmetal. So there's something called the activity series, which is a list of elements ranked in order of relative reactivity. Now, I like to think of the activity series as an upgrade plan, kind of like when you get a new cell phone. You want to upgrade. We have the highest activity at the top, the lowest at the bottom. So think of the newest, the best being at the top, and the worst being at the bottom. So a compound wants to upgrade. In reactivity, there's no reaction. The compound doesn't want the less reactive metal or nonmetal. So I take a look here. Zinc hydroxide plus magnesium. Here's my compound. I want to know what's higher, the zinc or the magnesium. So I look on my list. I have zinc here, magnesium here. My reaction is going to end up with something with hydroxide. I want to know if that's going to be the zinc or the magnesium. My hydroxide wants to be with my more reactive metal. My more reactive metal is magnesium. So therefore, my hydroxide would rather be with the magnesium than the zinc. So magnesium goes by hydroxide, and zinc is kicked out by itself. My next example, I have calcium and aluminum with my chloride. I want to know if my chloride would rather be with my calcium or the aluminum. So I look for them on the periodic table. I have calcium here and aluminum there. Chloride would rather be with the higher metal. My higher metal is calcium. So that means my chloride is going to keep the calcium and is not going to react with aluminum. So I would say no reaction, or we can write NR. The same thing can be done with nonmetals. If I look at the top, I had bromine with sodium iodide, and I said that they reacted together. But let's double check. I have nonmetal here. I have iodine, and I have bromine. Remember that my sodium wants to be with a more reactive nonmetal. Okay, so my more reactive nonmetal is bromine. So my sodium is going to swap out my iodine for my bromine and is going to kick out the iodine. So therefore, this reaction would happen. So whenever we see single replacement reactions, we need to double check our activity series to make sure that they happen. I like to go ahead and write them all out first and then go see.